Hi, everybody. Hope everyone's having a good morning, or if you're not on the West Coast, then whatever time zone you happen to be in, or time of day. My name is Sanderson, and I am the head of data platform on the product side at a company called Convoy, which is a digital freight technology startup. And data quality is extremely important to Convoy, and that's because data is extremely important to Convoy. Essentially, our entire business is built on the data we're getting about our customers, on shippers and carriers, and we leverage machine learning, all types of automation, and business intelligence in pretty much every single decision that we make. And that means that the quality of those decisions needs to be high, and it generates like real ROI for the company. And we ran into some problems with the quality of our data and the trustworthiness of our decisions. So pre-data contracts, the way things looked at Convoy was we were primarily capturing data from two main locations. In our first-party data is we were either using a tool like Mixpanel to capture events from our front end, not so much on the back end, piping those over to their SaaS platform, and then importing all of that data via Fivetran to the cloud data warehouse. We use Snowflake for that. And then on the other side, we were doing following that same process for our data in S3. We were essentially pointing a Fivetran connector at Postgres tables, importing all that data into Snowflake again. And so what essentially was happening is we had these big sort of data dumps that were arriving in Snowflake, which some teams then needed to, understand, figure out, sort through. And it really became a big mess, especially when we started moving to a more centralized system where each product team was responsible for their own business logic. And so what that resulted in was we ended up using a lot of tools, things like Amundsen, dbt, Airflow, and like fundamentally the quality of our data, the data itself that was coming over the wire from our production systems was not high quality. It wasn't designed for analytics or machine learning, and the producers of the who were generating the data really had no responsibility to ensure that it remained of high quality. So in the old world, we had a bunch of problems where, because we had these non-consensual APIs, we were just taking, mass exporting batches from production tables that no software engineer really agreed to. Then the data producers never took accountability of the data quality itself. The software engineers were not aware of how their data was even being used downstream at all. And so because of this mess that was arriving in Snowflake, it was really hard to understand what that data actually meant and from how was it being defined in production. We lacked a lot of documentation. A lot of the data modeling was not done in advance, which made things really hard. We didn't have a real source of truth. And there was an enormous cost to validate that the data we were bringing in was actually high quality. For a lot of our machine learning models, we ended up filtering out somewhere between 10 and 50% of the data, which meant that we weren't actually training our machine learning models on reality at that point. And so inevitably, something that should have really taken hours or minutes to understand inevitably ended up taking weeks. And so the core stance that we had here was that that just shouldn't happen. Science and analytics were first-class consumers of our production applications, and we needed to treat them that way. Our engineering team needed to treat data as part of the product, and that meant providing data over the line as an API. And the vehicle that we wanted to use to facilitate this transition was the data contract. So a data contract is an agreement between a producer and consumer on the data that's generated for some production grade use case. And that refers specifically to its schema, values, SLAs, and semantics. Why are data contracts sort of the right tool for the right job? Oh, the first thing is they define clear ownership of the upstream data. It facilitates a conversation between the producer of the data and the consumer of the data on like what's expected, why is it expected, what use case does it serve, and what is the value. And it also provides a single surface for semantic definition each contract is essentially is mapping to a single semantic object, whether it's an entity or an event. And that makes it really easy to do data discovery. And most importantly, it serves as a surface for collaboration between two teams that generally do not talk to each other. So the high level way of thinking about contracts is really you can, a very simple contract is just the schema itself. So ensuring that, the schema doesn't change in some unexpected way, that if you have a field that needs to be null, that it stays null. But you can very quickly dial up the complexity of the contract over time, focusing on, are some set of values always remaining the same? Is the business logic and the semantics of some particular column consistent? Is the latency, is the SLA as expected, and so on and so forth. So the maturity of the contracts really depends on where you are as an organization, but I find starting at schemas is the right approach. And there is a technological implementation here. In fact, we just published an article yesterday on how to implement data contracts from an engineering perspective. At a very high level, there's a few different pieces. You basically have a development workflow. We focus on protobuf as our contract definition surface. You define the schema there. After you define the schema, you can you then incorporate it into the CI, the checks, the integration tests into the CI/CD workflow of the software engineer. And so if those tests fail, if you're making a backwards incompatible change, then we can actually break the build. And then you have the ability to publish those schemas through the Kafka schema registry, push it via Kafka through an entity topic, as we call it, into the warehouse. And that's generally the way that it's managed. So there's a lot of complexity into this system, but I find it's an awesome place to get started, is referring back to that article. And today at Convoy, we have roughly 300, I think maybe 320 to 350 contracts that are actually in production, that are and thousands of changes are made to those contracts every month. There's a lot of collaboration around them as well. So big takeaways for contracts is that they're really critical for production grade data pipelines. So when you have some use case that requires quality, the generating the contract is actually an act of collaboration between the producer and the consumer. Being able to enforce the contract is critical. We do so in the CI/CD pipeline by breaking the build if the contract is not being met. Didn't talk about this too much, but abstractions just make it a real easy implementation and nicer for the software engineers. And then the goal is to eventually focus on the definition of the semantics in production systems, not just accepting sort of what we're getting from these more operational use cases. So there is a guide, an implementation guide. Here's the link. I have a Substack just called Data Products. But that's it. That's my talk. Thank you.